this recording. All right. So going to the first question, what is meant by centripetal acceleration? Haven't we done this before?
Yes, sir.
How come this is the same? Yeah, I think I've done this before. I clearly remember this. This is October, November 21. How's that even possible? June 2021. Okay, let me check. According to our paper list, today was October, November 21. So why it is so similar? June 2021 4/1. So we haven't done this. June 2021. Yeah, we did this. This is a completely different one. June 2021 4/3. Okay. All right. So we have already done March as well. So March, February, March 2021. How did we do? Maybe I've done it in some other place, not here. Shayan, do you remember me doing this paper?
No, sir.
No, right? Okay. All right, so we'll do this then. Take equation 4/2. Okay. Somehow I have done it somewhere. Just it's in my memory. Okay. State what is meant by centripetal acceleration. So we would say that centripetal acceleration is the acceleration acting towards the center of the circle and is always perpendicular to tangential velocity. Okay. Now going to this one. State what is happens to magnitude of centripetal acceleration. So I just want to tell you people that when you go from like here, naturally it will be larger, it will be smaller. So it should, from x to y, it should decrease. That is because the resultant force decreases. That's all.
सर वैसे इसमें इस केस में सेंट्रिपेटल फोर्स है क्या चीज प्रोवाइड कर रही है?
Here it will be the reaction and weight. So reaction minus weight equals to centripetal force, right? So yeah. In that case, the reaction and the weight is in the similar direction. So weight plus reaction is centripetal force. So basically, when you see the reaction, so it will be Fc plus W. So it's much larger, right? And in here, reaction is Fc minus W. It's much smaller. That's why it decreases as you go up. Okay.
सही है सर.
दूसरा इसका जो है ना एक और समझने का बेसिकली तरीका वो एक और भी. If you notice na, here it will have maximum kinetic energy, here it will maximum gravitational potential energy, right? So kinetic changes to gravitational potential energy, and according to the formula F equals to mv square over r, the velocity If it decreases, then FC would decrease. Don't you think so? Yes.
सही है sir.
Now, explain in terms of car remains in contact with track, why centripetal acceleration point y must be greater than 9.8. So it should be because 9.8 meters per second is due to weight of car, right? So acceleration greater than 9.8 means that the car will stay in contact with the track. I just need to लिख दिया reason बताने. Sorry. So instead of that, acceleration greater than this would mean that
Sir, इसमें ये दोनों
वो
की
equation
acceleration का
बनाएंगे. Not big deal. अब ये equation बनाइए ना. So we have to write that contact force is required. Hence, centripetal force must be greater than weight. Do you understand? Like that. Should be like that.
सर
Now,
लेकिन इस केस में FC और W दोनों सेम डायरेक्शन में है तो वो एड अप नहीं हो जाएंगे चाहे कुछ भी कर ले
FC is not a force that basically you should understand. FC is not a force that is a original force. It is a resultant force. It comes from other forces. Okay. So इधर जो है it is FC I mean W plus the contact force. Okay. These two make up FC. Understood?
सही है
So we need this, right? So naturally, if you want this, then FC should be greater than W. Otherwise, you won't get this, right? If it's equal, then it will be 0. It will just lose contact. Do you understand what I'm saying?
सही है सर
Now, the initial speed at which the car is moving along this determine whether the car contact show your working. Now, according to me, there will be kinetic energy at y. So kinetic energy at y equals to kinetic energy at x, right? So at y, kinetic energy should at x should be like due to the gravitational potential, right? So some of it is going to be subtracted from x. It's just starting like that. So this will be half mv at y square. This will be half mvx square, right? Minus mgh, right? So m from all of them is going to cancel out, right? So m cancel out. So what you do? Okay, so here it will be half times 3.8 whole square, right? Because that's the speed. किधर गई speed? अभी तो मैं पे पढ़ा था 3.2.
सर नीचे दी हुई है सी में ही दी हुई है
अच्छा हाँ ये थी 3.8. Okay. Minus 9.81 and the height would be basically the diameter 62. 62 centimeter can be written as 0.62. And we got to find Vy square. So 2 से multiply करेंगे. So this will be 3.8. 2 times 9.8. Now let's try. So, and under root answer. So Vy should be equal to 1.51. Okay. See, okay. Then say suggest with a reason without calculation whether your conclusion C would be different for a car. This no. And the reason it won't be different because the reason it is not
determine whether sir उसने कहा determine whether the car is in contact तो हम क्या बताएंगे?
Good question. ये तो मैंने बताया ही नहीं. So अगर तुम देखोगे इसके बाद ना we also need to find acceleration there. So acceleration is equal to 1.51 whole square and the radius was 62 diameter is 0.31. This is A equals to V square over R, right? So we have to check this. Sorry, I forgot totally. कि ये पूछा उसने 1.51 square divided by 0.31 ये आ रहा है 7.3 7.4 since 7.4 is less than 9.8 so will not stay in contact. Is it clear? All right, then going to this, so acceleration because is equal to v square upon r, so acceleration is independent of mass. I hope that's clear. Any questions now? Now going to part 2. State the relationship between gravitational potential and gravitational field strength. Okay. Gravitational potential and gravitational field strength. So you can write anything about this. It's not a big deal. You could say that they are potential gradient. Okay. So gravitational field strength is negative potential gradient. I can hear a very squeaky sounds. Why? Whose microphone is on? Malika? Mute. Okay. So gravitational field strength is negative potential gradient. That is the definition of it. Anyway, now in this part, it shows you a graph. There is a moon and there is a planet, whatever. And then say explain why potential is negative throughout the entire range. For 3 marks, if I were you, I would write it like this. Potential at infinity is 0. Right? Second mark, gravitational force is always attractive. Third mark, anything before infinity, or if we go closer to a mass, gravitational potential is lost, right? So it means it loses or becomes negative or whatever you want to write. Now, one feature that is negative throughout, ये तो हमें पता है कि it's below this line, so it's all negative. It says describe 2 other features. If you look at the 2 other features, one of them is that the potential here, if you the gravitational field strength is like this, the gravitational field. So we could say that potential, if you look at it, there's a huge difference between these 2, which means that potential at moon is smaller. No, larger. Larger than planet at its surface. Now, why am I writing larger? Because the smaller the negative value is in magnitude, it is considered the higher value. Okay, that's it. And then you could always say that if you look at it here, the tangent is like less steep than that. So we could always say that the gravitational field strength, hello, बोलो नहीं है. All right, so the gravitational field strength is basically smaller at surface of planet than moon. So you can write like this, right? Then says sketch the gravitational field strength. Now we have to be a bit, So gravitational field strength at the surface, if you look at it, it's less steep. So it's like this, you see? It's like the gradient is positive and it's less steep. Here, the gradient is negative, but it is steeper. So when you say electric field strength is negative potential gradient, it means that this value should be negative. It will be turned negative in its graph, and this will be positive. So let's try this. So at 2r, it will be negative with a smaller value. And then if you look at it, the gradient becomes 0 right somewhere, here, which is somewhere like 1, 2, 3.5 boxes. So this line will basically go 1, 2, 3.5. So this line will go right here, and then it will go this way. So this should be the graph. All right.
So इनकी heights के बारे में
Height
कुछ
ये smaller होगा, ये bigger होगा, because gradient define आपको बता रहे हैं इस surface के ऊपर I checked with which is steeper. So at moon it is steeper, so moon पे ज़्यादा height बना. All right. So
Sir,
this is
opposite बनाया हुआ हो तो
well opposite नहीं बनना चाहिए, लेकिन I don't know, sometimes वो allow कर भी देता है, but it should be like this. All right. Now going to question number 3. One of the assumptions of kinetic theory of gas is that all collisions involving molecules of the gas are elastic, right? So state what is meant by elastic. Elastic collision means kinetic energy before and after collision is conserved, right? State 2 other assumptions of kinetic theory of gases. two other assumptions of kinetic theory of gases. Okay. Now, two assumptions पहले इसने कौन सी बता दी? Okay, elastic collision वाली बता दी. So there are so many things you can write. Molecules have negligible volume compared to container, right? So you could write that. You could also write that there are no forces of attraction or repulsion between molecules. So there are other things as there should be enough particle statistical, approximation. Collisions are the time interval between the collision and the time of collision are negligible. Like that, you can write this. Okay, then it says change in momentum. So if it has a mass m, it is going here, and then it reflects with the same thing. You take it as negative, you take it as positive because momentum is a vector quantity. So change in momentum will be mu minus mu. So that should be 2mu. Then it says calculate the consecutive collision. So it should travel this way, this is length, and then come back. So that it has to go twice the length to make one collision. So this will be 2L is the distance, over speed is u, so it should be time. Right? So this is just distance over time, velocity. Okay. So then it says average force. So force, is change in momentum over change in time. Change in momentum is 2mu divided by 2L over u. U will multiply top, 2 will cancel. So it will be mu square over L. Right? Then it says the pressure on the shaded force. So pressure is force over area. Area has to be length square. So the force we have already done, mu square over L over length square. So this will be mu square over length cube. Yeah, again. Now they have given this, and they say show that this exists. So that's pretty simple. Use the expression to show. PV equals to NKT, and PV equals to 1 by 3 NMC square. So you put PV together. So it is going to be NKT equals to half NMC square. N and N cancel out. This means that KT equals to 1 by 3 MC square. 3 को multiply कर दो उधर. So 3 KT equals to MC square. Now multiply half on both sides. So this will be 3 by 2 KT equals to 1 by 2 MC square, which is equal to kinetic energy. So it is proved. So that's all you got to do. Then it says the mass of hydrogen is given. Use the expression, determine RMS. So that's pretty simple. What you do? Kinetic energy निकालनी है हमने. Okay, नहीं, C निकालना है. Half times 3.34 times 10 raised to minus 27 times C square equals to 3 by 2. K is 1.38 times 10 raised to power minus 23. And T 25, 273 में 25 right. Okay. So what you do? You gotta do 3 divided by 2 multiply by 1.38 times 10 raised to power minus 23. And then multiply by 273 plus 25, 298 divided by half divided by 3.34 and divided by 10 raised to power minus 27. Okay, this, so c squared equals to what is this? No. 3.7 times 10 raised to power 1, 2, 3, 4, 5, 6, 6. So c is going to be under root of this. Oh my god, कुछ हो गया, गड़बड़ हो गई. So this is 1924, which is 1.9 times 10 raised to 3. If somebody has a question, please let me know. Now, everybody understand this? All right. Now going to the next question. It says a trolley in a smooth surface is attached by springs to fixed blocks as shown. Now it says they have given a graph. It says describe the features of the line, demonstrate that it is simple harmonic motion. So simple harmonic motion depends on this, right? So first of all, they are directly proportional, as you can see. So it should start from origin. And the other thing you notice that it is a straight line, and it should be of negative gradient. Please write negative like negative, not like. All right, so that's why this will show you that there's a minus sign here. Use the time to determine the oscillation. Now you need to basically make a sort of a gradient, right? So we would, it's easier to take 0 and 0, and here you could take 12 minus 12 is 0.8. So when you find the gradient, right? So gradient got to be excitant. Hello. Okay, so the gradient is going to be this, and minus 12 divided by 0.8. So this is going to be minus 15, right? Now what you do? The gradient is equal to, how do I know the gradient is equal to this? Because I can actually put it like mx. So this whole thing, I mean, yeah, that is gradient. So minus 15 equals to minus omega squared. Now 15 equals to, omega is basically 2 pi, we need time period, so 2 pi by t whole square. And we got to take under root 15, 2 pi by t, and then t will be equal to 2 pi over under root 15. So we're going to find that. So 1.6. Okay, 1.6 seconds. Very good. Now it says on the line level.
Sir,
Yeah.
2 pi over t. सर कुछ तो मैं सर इसका किया मेरा 2.4 आया था।
हाँ सर 2.4 है 1.6 नहीं है।
मार्क्सिंग सी में 2.4 है जी। बट व्हाई? इसका मतलब ये कि कहीं तो गड़बड़ हो गई ना हमारी। व्हाई माय फ्रेंड्स, व्हाई 1.6 क्यों आ रहा है हमारा? ये आपके भी कैलकुलेटर भी यही आ रहा था जी। देखा मैंने उल्टा ले लिया, सॉरी। असल में होना क्या है 0.8 minus 0 and minus 12 minus 0, उल्टा ले लें gradient. 0.8 divided by 12, what is that? Yep, it's 1/15 आया minus में, उल्टा हो गया, sorry. इसको हम 1/15 लिख लेते हैं, ठीक है. Now let's try this. So, oh my, 2 pi over root of 1 divided by 15. Oh my god, क्या complex number है. ये
Sir,
सही है.
मेरे पास भी 24 आ रहा है लेकिन मार्क्स की में 2.4 है.
2.4
यार हमारे साथ ऐसे क्यों हो रहा है? क्यों हो रहा है? हमारे तो सही है हमारी वैल्यू.
सर आप x की वैल्यू क्यों नहीं ले रहे?
x की वैल्यू चाहिए नहीं ना.
तो
ये
सर आप
x,
वो सेंटीमीटर में दिया हुआ है ना, x सेंटीमीटर में दिया हुआ है.
हाँ, that is also good. That is, this is why it was 0.24. अब आ जाएगा. Bassam is right for the very first time in his life. So 0.8 divided by minus 0.12. So that should be the gradient. Why am I making
6.67
0.
6.67
Okay. All right. Now what to do? 2 pi t whole square minus something.
सर
So
0.08 नहीं होगा?
वो तो meters per second में already है मेरे में, right?
ओह हाँ सही है, ठीक है.
2 pi over under root 0.0667. आप देखो सही आता है. Okay. 2 pi over under root 0.6. अभी भी सही नहीं आ रहा. What is happening?
तो अंडर 6.67 करें.
6.67
Under root 6.67. अच्छा. Finally, it came correct. Oh, मुझे लग रहा है मैं रोजा लग गया आज. एक calculation ठीक है. 2.4 seconds, right? Now, on the line, show letter P with the kinetic energy is 0. Kinetic energy will be 0 at the extreme points. Your displacement is other. And then on the line, label Q, approximate position of where kinetic energy and trolley are equal to potential energy. So, kinetic energy is basically equal to half m omega square x naught square minus half m omega square x square, right? And this is potential energy is equal to half m omega square x square. So कहने का issue ये है कि total में से it will subtract this and then. So it means that exactly where they will be equal, right? They will be equal somewhere more than half value. Somewhere here. So that should be Q. Right here. Because you see, in order to completely be similar, there is a factor of square here. And then it has to be subtracted from total energy. So that's why. All right.
सर क्यों बिल्कुल बीच में क्यों नहीं है?
बीच में नहीं हो सकता ना. Directly, there is a relationship, right? Relationship is there is a subtraction happening here. This is total minus gravitational. Sorry, not gravitational, potential, right? So this is kinetic energy. Now it can't be exactly similar because it is not directly proportional to this. There is a total that is subtracting through it. Understood? So it has to have that. It has
ग्राफ
to have
बनता
that.
तो कर्व था.
So इसका थोड़ा सा इसके इंटरसेप्ट मतलब होगा, मतलब ग्राफ बनाते तो फिर इंटरसेप्ट आता. Do you understand?
So ये कैसे पता कि नीचे होगा और ऊपर नहीं?
क्या मतलब नीचे होगा?
मतलब Q P के ज़्यादा पास होगा, जीरो ओरिजिन के ज़्यादा पास नहीं होगा.
You mean zero के ज़्यादा पास नहीं होगा? क्योंकि at any point, you know, as it will decrease, so kinetic energy is also increasing because total is there, right? That's fine. Total की तो fixed value है ना?
हाँ.
So अगर kinetic energy exactly potential energy half भी हो जाए, right? So we could say that exactly half के ऊपर भी ये हाफ हुई है, इधर आया है जहाँ पे 12 से 6 पे चला गया है, लेकिन टोटल एनर्जी से जब माइनस होगा so it has to be greater than that. That's fine. It will still be moving, you know. That's the idea behind it. वो cannot be less. अगर कम हो गया तो then you defy the law of energy. That's all. Do you understand? Okay. Now, question number 5 is not required. It's done and dusted. Electric potential. Electric potential जो होता है, electric potential is basically the same definition, that is work done per unit charge and in moving a positive charge from infinity to a point within the field. Now it says show that the capacitance is. So V is equal to KQ upon R and C is equal to Q upon V. और हम ऐसे कह लेते हैं इसको इससे Q is equals to CV. So you're going to put it here. So V is equal to K C V over R. So V and V cancel. So C will be equal to R upon K. Since K is equal to 1 upon 4 pi epsilon, then this will be 4 pi epsilon R. Okay, then it says we have a potential of 13 and 4.5 and isolated surface radius brought near to dome, sparking pauses until charged, right? So it says it discharges into other and then something happens, right? Now, in this question, okay, all right. So if we get to know the total charge, then we can easily divide it, right? So how about we find total charge first? So according to that, then capacitance is 4 pi. Well, I don't want to use this. I want to use RK. So this is C is equal to Q upon V. So Q will be equal to RV upon K, right? So शुरू में radius था 13, 0.13. Voltage was 4.5 kilo. Kilo means 10 raised to 3. And K is 8.99 times 10 raised to 1. Can you please do it with me because I'm making wrong calculations today.
-6.5 times 10 to the power -8.
6.5 times 10 power negative
-8.
-8. Okay, coulombs. Okay, so we got the total charge which was supposed to be initially there. Now we need to understand something. If this was the dome with the charge Q and this is a dome there with the charge small q. So when the sum of the charge travels here, so just to make an equation, right? Just to make an equation, we need to understand that at one point the voltage is going to be the same. which basically gives me this idea, you know, that suggests that Q is directly proportional to R, and then I could write as Q1 equals to QK R1, and then I could write as Q1 over R1 equals to Q2 over R2. So I can make a relationship. That gives me an idea. Now think about it this way. At one point, when their voltage is going to be the same, then this side will have, this will gain charge Q, and this side will have a new charge, which is basically the one that is subtracted from here, like this. Do you guys understand what I'm saying? So what I'm saying is, let's suppose if it had 100 coulombs and 20 goes there, so the new charge will be 100 minus 20, so it is going to be 80, just like that. Okay. Now, we already have the total charge, so don't have to worry about it anyway. But now we will put it. So Q minus Q over R1 is 13, I believe. And this is Q and R2 is 5.2 right here. What else do we need? Nothing else. So we are going to just write 5.2 Q minus 5.2 small q. This is equal to 13 Q. And then we're going to subtract this. Plus 5.2 Q. So 5.2 Q equals to 13 plus 5, 18.5. 18.2 Q. Now we want to find the charge that is transferred. We want to find Q, right? So we are going to write it like this: 5.2 times Q over 18.2. Now Q we have already found out, so we're going to use this. So 5.2 divided by 18.2 multiplied by
0.85 times 10 to the power negative 1.
So 0.85. Okay, 0.85 ये तो कोई आंसर ना हुआ.
So 1.85.
अच्छा 1.866. Correct. वो करना है. Yes, 10 raised to power minus 8 coulombs. Do you guys understand this?
Yes, sir.
This was a very tricky question, but that's fine. Okay, so op amp is gone. Hi, such an easy thing. All right, then 8. So current in I, current Q. So it says draw an arrow to show the direction of magnetic field. So due to current in wire P. So of course he used the grip rule, Maxwell, and it goes like this. You can check with the grip rule. So this means that here the arrow, like it will turn like this, right? So here it will be like this. Now it says draw another arrow to show the direction of force acting on Q. So it should be here, perpendicular. Why? Because when two wires are the same similar current, they attract. State with the reason how the magnitude of force Q acting on P compares with the magnitude of this. That's pretty simple. So magnitude will be same. And how many marks is this? I think it's just 2. Magnitude is same because according to Newton's third law. Okay. So state the direction of force P compares to direction of Y. So they will be opposite as well. They just want to state, so no explanation, they will just write opposite. Why? Because every action has an equal and opposite reaction like this. All right. Then says what is meant by the photoelectric effect? Emission of photoelectrons from a metal surface when an electrostatic magnetic radiation is incident on it. ठीक है? Work function क्या होता है? It is the minimum energy required for an electron to leave the metal surface. Now it says state the name of frequency below which no threshold frequency. Then say explain how the photon model electromagnetic accounts for this phenomenon. Now you guys need to understand that photons are indivisible and discrete packets of energy. Number one, 3 marks se likhna. So frequency of EM radiation determines photon energy. How do you know this? By E equals to HF. And third thing, each electron absorbs only one photon. So there is one-to-one relationship. It can't be one-to-many. अब वो कहते हैं calculate the work function. So we already have the frequency. So work function is equal to HF naught. 6.63 times 10 raised to minus 34, and F is 6.93 times 10 raised to 40.
4.59
Sorry?
10 to the power 4.59 times 10 to the power -19.
Negative 19. Okay, so this is the joules, and we need to find an EV. So 1 EV so that is going to be
2.87.
2.87.
2.87.
Okay, that's good. So that's pretty simple, right? Then here, state the function of iron core. How many marks? 1. So that is pretty simple. To increase, you can also write strengthen, magnetic flux linkage. Explain why iron core is laminated. 2 marks के लिए to reduce energy losses as less amount of eddy currents are induced. If this was 3 marks, then we would add a point that by making the resistance higher. Okay. Now, then says the Vn in the sinusoidal alternating of peak. This period is this. Calculate the maximum value of output. Okay. Whoa. So what you do? You have peak value already. V in that is 12 kilowatts, 25,625. So you can use Vp over Vs equals to Np over Ns. So Vp is 12 kilowatts. We want to find Vs. That is 25,625. Okay. Can you tell?
300.
300. Okay. That's good. 300 volts. Now it says calculate the RMS current in the load resistor. Where is the load resistor? Oh, okay. This is not hard, by the way. So you have the maximum output. To find the RMS current, you need, V equals to IR. And you need RMS. V RMS, I RMS times R. Okay, so 640 ohms R, right? So V RMS निकालने के लिए it will be 300 over under root 2. So 300 over under root 2 divided by 640. 640. Yeah. So the answer is
0.331.
0.3. Okay. Well, it should be written as 30 then. Okay. Then
0.33 है.
33 है. Malika, आप क्यों significant का ख्याल नहीं रखते? You know how important they are.
Yes, sir.
So I told you last time as well that you need to follow that rule. Okay? Now, sketch a variation of time power dissipated in load resistor and this. Okay. This is something we got to do. We have the resistance. We have the voltage, we have the current. Okay. Power equals to I square R. So RMS से तो हमने नहीं लेना है. So we shouldn't really do this. So instead of doing this, we could use V square over R. V क्या था हमारे पास maximum 300 square over 640. Can you please find the answer here?
140.6.
140. So 140.6. So about 140, 141 जो भी है. This is 150, I believe. So around here or something. You have to search it on your own. It has a period of 240. There will be sinusoidal wave. 40 milliseconds. 40 means that this is 180 degrees. So exactly at 10, it will show you a peak value around 140. And then it will come down. And then here it will be minus 140 somewhere here. You have to look for it, okay? Like this. So it should be like this. Is it clear?
Yes, sir.
See my maximum here at any cost. But I have another problem. If this was the voltage, like it kept on changing, power cannot be minus. Don't you think power cannot be minus? Huh? It's not right. It should be like this. I think it should be like this. You know why? Because voltage can switch, but when you put a square on it, it has to come to the top. So being 140, 140.6%. Do you guys understand? It should not be in minus at all.
सही सर मैंने ये गलती कर दी थी.
Yes, should not be like that. Okay, then it says explain with reference why mean power and load resistance 70 watts. Ajab, with reference to this, you guys need to just show it like this, right? That it is like, if you check it like here, you see that there are two halves of it, which means when you add both the maximum powers and you divide by 2, that means the mean power will be half, right? So if you try to take the mean. So you could always say that it is add both maximas at max points, and then what you do? Mean power will be equal to peak divided by 2. You could say that, right? Because mean means if you take it like half of it, half and half like this, so you could say that. Max point, बल्कि हम ये ना लिखते हैं, हम लिखते हैं कि they both have the same shape after every 20 milliseconds, like this. So that could be better.
तो ये वाला पॉइंट लिखने से क्या बता रहे हैं आप?
हम ये बता रहे हैं कि ये आपस में सिमेट्रीज है, इसकी सिमेट्रिकल, दोनों सेम शेप है ना इधर. सो इसको अगर ऐड करो और इसको अगर ऐड करो, टोटल डिवाइड बाय 2 करोगे तो आ जाएगा ना 70. Do you understand?
सही है.
Because they're symmetrical. और you could say half power में ये देख लो, ये भी symmetrical है इसके साथ तो half. So after every thing it is symmetrical, right? That's what we're telling. Now, question number 11. Describe the function of quartz crystal. Function of quartz crystal. अच्छा हाँ, ये quartz crystal बहुत आसान है. उसने कहा वो करता है, it generates ultrasound. Also detects ultrasound. And ये ऐसा होता क्यों है? क्योंकि EMF causes it to vibrate, to generate, and vibrations, जब ये वापस आती है ना, vibration causes it to produce EMF. So वो detect करता है. So that's the way. Then it says define specific acoustic impedance. So this is the product of density and speed of ultrasound in the medium. Let's say describe qualitatively how specific acoustic impedance of two materials affect intensity reflection coefficient. ये मैंने पहले बताया. If Z1 is greater than, way too larger than Z2, right? So they will have larger difference, means greater reflection. You can also write coefficient reflection. If Z1 is approximately equal to Z2, it's not that bigger, right? So larger transmission. Do you guys understand this? So this should be, if these two are nearly 1 and this is nearly 0, then this is what is happening. So if you want to go back, you can go and check gel and air wala jo example. उसके बाद रेडियो डिके वो तो रैंडम क्या होता है, स्पॉन्टेनियस क्या होता है? आई थिंक वी कैन डू दैट. रैंडम का मतलब है कैन नॉट बी प्रिडिक्टेड when any or one nuclei or nucleus decays. These will be predictors. Spontaneous का मतलब ये है कि decay is unaffected by external factors like pressure, temperature, etc. They've given you ln and T minimum. Determine the half-life. Okay. Now, to determine the half-life, this is a 3-mark question. The first thing I should remember is that activity की terms में क्या बना? Okay, is E minus lambda T, right? A upon A naught, बल्कि नहीं ऐसे नहीं करते हैं. हम इसको ln A लेते हैं because here there is ln A. So this will become ln A naught plus minus lambda T. So if you know logs, if you don't understand, let me know. So ln A then will be equal to minus lambda T plus ln A naught, which is equal to y equals to mx plus c. ठीक है. इससे पता चलता है कि on the y-axis we have ln A, on the x-axis we have t. So the gradient is minus lambda. So we have to find this, right? अब इसमें any points you wish to take, right? Any. So पहला point बड़ा आसान है ये वाला. I think it is 36.4 and on x-axis it is 0. So this is 1 point, and here this is 35.0 and 20. So 20 minus 0 और उसके ऊपर 35.0 minus 36.4. What is the answer? Can you please find?
minus 0.07.
Minus 0.07 minute minus 1. ये आ गया. अब we have this. So lambda is basically my 0.07 per minute. Now to half-life is given by ln 2 over lambda. Can you find this?
10 minutes.
Sorry?
10 minutes.
10 minutes. Okay, so 10 minutes is our answer. Wow. Quite a work for 3 marks.
सर मैंने डिफरेंटली करा था.
कैसे किया था?
सर ln A नॉट जो है मैंने ग्राफ से देखा क्या है 36.4 था, तो उससे मैंने A नॉट निकाल लिया और A नॉट बाई 2 जो है वो 3.2 टाइम्स 10 पावर 15 था. उससे मैंने देखा कि वो ग्राफ पे वैल्यू क्या आएगी ln A की, और उसका टाइम मैंने देखा कितना टाइम लगा है.
ठीक है. Anyway, that's fine. So at a time t0, the mass of atom X in the sample is this. Determine the nuclear number of X. Interesting. So it says there's a mass. Fine. Oh, wow. Now, we have the half-life. We have lambda. At time equals 0, the mass of atom X in the sample is determine the number of nucleons. Okay. Now back. या तो इस जा सकते हैं ना. नंबर ऑफ न्यूक्लियन हमने निकालना. मैस हमें मालूम है, हाफ लाइफ है, और कुछ हमें नहीं मालूम इसके बारे में. nothing else.
सर ए को लैम्डा एन से पहले एन निकाल लें।
नहीं, हम इसको ना मोल से करना पड़ेगा मेरे बच्चे, हमें इसका एमआर चाहिए।
जी सर, एमआर के लिए कह रहा हूँ, एन निकाल लें तो एमआर आ जाएगा।
ये आपको ये ओवर एमआर इक्वल्स टू एन अपॉन एन है, राइट? यही करना है ना?
जी सर, तो पहले एन निकालेंगे ना, कैपिटल एन।
कैपिटल एन निकालना पड़ेगा, ये बात तुम्हारी बिल्कुल सही है, दैट इज ट्रू। सो इसके लिए हमें ये चाहिए एम आर, उसके लिए हमें चाहिए एम जी टाइम्स एन ए ओवर एन। सो ये हमारे पास है, ये हमारे पास है, ये निकालना पड़ेगा। कैपिटल एन कैसे निकालेंगे? ए इक्वल्स टू लैम्डा एन करके, टाइम 0 के ऊपर द एक्टिविटी एल एन के अंदर गिवन है 36.4, राइट? सो एल एन को रिमूव करने के लिए हम एक्सपोनेंशियल ले लेंगे 36.4 का, ये एक्टिविटी आ जाएगी, लैम्डा 0.07 और एन आ जाएगा। ये एक्टिविटी हमारे पास, हाँ ठीक है, मिनट्स में आनी चाहिए जी। कैन यू प्लीज फाइंड दिस? एन कितना आता है? Slow people. बड़ा ही वैसे मुश्किल है यार। ओके,
9.2 times 10 power 16.
है इतना ज्यादा है?
16
सर।
16 sir, 16.
मैंने कहा 60। ओके फाइन, अब हम लिखते हैं मास इन ग्राम्स क्या हो जाएगा? 5.66 टाइम्स 10 रेज़ टू पावर -4 है ना, ऐसे हो जाएगा केजी को। एंड देन Na क्या आ जाएगा? 6.02 टाइम्स 10 रेज़ टू पावर 23, 9.2 टाइम्स 10 रेज़ टू 6। कितना आता है? कैन यू चेक प्लीज?
Sir, marks की में 62 है आंसर।
हमारे क्या आ रहा है? डोंट केयर अबाउट मार्क्स, ये बताओ।
एक सेकंड।
Why are you guys so slow?
Sir, 3,703.
Oh my god. Like this? इतना बड़ा नंबर? This is not
Yes.
possible.
Yes.
ये तो पॉसिबल नहीं होना चाहिए ना। How is it even possible कि हमारे पास ये नंबर आ जाए? कहीं तो हमने गलती कर दी है फिर। ये सही है? ये सही अगर है, क्यों? जिसको वैसे हमें मिनट्स में नहीं लेना चाहिए, एक्टिविटी पता नहीं पर सेकंड में ही होनी चाहिए बेकरल्स में। शिट, इसको मिनट में लेना चाहिए था। माय बैड, ये गलती हो गई यहाँ से, सॉरी, दोबारा करना पड़ेगा। 0.07 पर मिनट है, राइट? सो ये इसको 60 में डिवाइड करो, कितना आता है? अब करो इसको, लाइक
Sir, 1.17 times 10 power -3.
वाओ, 1.17 टाइम्स 10 रेज़ टू पावर
-3.
-3। अब ये हमारे पास आती है, ये क्या आ रहा है? एन आ रहा है। अच्छा,
ये ये लैम्डा आ रहा है।
अच्छा लैम्डा आ रहा है, ठीक है। सो लैम्डा ये आ गया। इसको अब हमने n निकालने के लिए वी गॉट टू डिवाइड E36.4 डिवाइडेड बाय दिस। अब n हमारा गलत है, इसलिए इतना बड़ा नंबर आ गया। The answer is
5.5 times 10 to the power 18.
18, right? अच्छा अब करो जरा इसको। हाँ 61.9, right? So 62, perfect, आ गया। Oh, all right. So that marks the end then. And I guess I'm going to see you in the next class then. I'm super tired. Irda, Manahil, why are you guys late? First of all, tell me this. Manahil, I can't hear you.